this is Miss Bowen from PEP Practice. Today we're going to be looking at the grade 4 mathematics sample item. This is the 2019 performance task. Similarly to the grade 5 performance task, there has not been an admission of a performance task since the 2019 grade 4 performance task. So this year would be the second time administering a performance task, or the second year. So we had a performance task done today, the language arts performance task. The grade 4 students will complete the mathematics performance task. Tomorrow, I wasn't able to do a video on the language arts performance task. I'll do another one afterwards for next year's grade 4 students, seeing as though this year's grade 4 students would have completed that task today. I hope you all did well and you're all tuning into this live video, or it will be shared to you hopefully by tonight, sometime tonight. So you can, yeah, I'm just sorry about the late posting, bear with me. But for whatever it's worth, I hope it does get through to someone still, and it would be helpful to them for their examination tomorrow. So let's get into the paper. So I'm going to go ahead with the instructions. The instruction reads, read the introduction to the task below, then answer all the questions that follow. So the introduction to the task of the task is starting a chicken farm. The introduction is that your school wants to start a chicken farm in order to provide meat for the canteen and to raise funds for the school. There is a plot of unused land to the back of the school that the principal has identified to place a chicken coop for the farm. You have been asked to help your principal to determine the number of chickens the coop will fit, determine the number of feeders needed, and to calculate the cost of the feeders needed. Question 1 is, the rectangular base of the chicken coop has a length of 10 meters and a width of 4 meters. Draw the outline of the base of the chicken coop on the grid below. Each square represents 1 meter square. So here is 1 meter, from here to here is 1 meter. And so the length of each of these small squares is 1 meter, and the width is 1 meter. And to find the area, we multiply 1 meter times 1 meter here, and meter is represented in square. So therefore, the area of this square is 1 meter square. So let's try to find the length of, or outline the length of the chicken coop. And it says it's 10 meters. So as I said, from here to here is 1 meter. So we can draw a line, go down 10 squares. We can just count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I won't be drawing as straight. Really, not straight as I thought. And let me see if I can get my straight hand. All right, the straight hand looks like it's coming along. That's 3 meters, 4 meters, 5, 6, 7, 8, 9, 10. You could actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You could actually just mark here. That's what I'm gonna do for the weight. Mark it 1, 2, 3, 4, and mark it here, and I can draw it. And you can place this anywhere on the grid. Doesn't necessarily have to be at the corner that I'm using now. I'm just gonna go ahead. That's just a small error. That's an outline simply means that you're putting a line around it, the outer part of it. That's why it's called outline. I'm gonna go all the way down. And you should try to use a ruler if you have one for the examination, so you can get it all neat. But if not, you can just do it like this. I don't think they would penalize you. So that's my 40 meters. This is something that I always do. I just always try to label my diagrams. And I know if here is 10, then the other side is 10. And then up at the top is 4. And at the bottom here is 4. All right. And I always just say in. So that's my diagram there, and I would get the full mark for that. That's outline. So this item required us to model mathematics by applying our knowledge of error to an everyday life situation, which involves drawing the rectangular base of the chicken coop. And our objective was to use unit squares or centimeter grid to cover regions so as to determine the error, and it was from the measurement strand. Let's move on to question 2. Question 2 says, what is the area of the base of the chicken coop in meters square? And we can just go ahead and write a formula or an equation for area. So we can say area of the chicken coop, or any area of a, and that was a rectangle. By the shape of it, they're not equal lengths or equal widths. So it would be a rectangle. So the area of a chicken coop, and it already says it's a rectangular base. So we'll multiply the length, and I'm going to use length multiplied by the width. So the length was, for my writing too, so the length was 10 meters, and the width was 4 meters. So now I can multiply 10 by 4 to give me 40. And as I said earlier, the area is measured in squared, so it would be 40 meters squared. So that's the area of my chicken coop. All right. This was also from the measurement strand, and our objective was to use a square grid, 100 centimeter, sorry, 1 meter centimeter square, 1 meter square, to find the area of any shape. In this item, we were required to solve a pure mathematical problem by demonstrating our conceptual understanding of error by counting squares or using a formula. And we did the formula here. When it says counting squares, you could actually go up and count here. It's 4 across, 4 again, 4 again. And then we know 4 times 10, or 10 fours will give us 40. Or we could go across like this, 10, and then 10 again, 20, and then 10 again, 30, and then 10 again, 40. So either way, we could get the area, even if we didn't know this formula here, by just counting up the squares on the rectangular plot. So let's move on to question 3. Question 3 is also from the measurement strand. So we see that a bulk of this, are a bulk of the questions from this performance task were taken from the measurement strand. The objective in question 3 is to demonstrate an understanding of the units of length and the units of area. So for question 3, it reads, each chicken coop needs a floor space of approximately 1 meter square. What's the maximum number of chickens that will fit in the coop? All right, so we should show our work. In this item, we're also, again, required to solve a mathematical problem applying our knowledge of everyday life, of area to everyday life. So to find the maximum number of chickens that will fit in the coop, we will use the area. Which we just got, which is 40 meters square. And what you must notice about a performance test, I think we saw this when I was doing the grade 5 mathematics performance test, is that for each question, you were bringing down some information. And not only for the mathematics performance test, we just saw it in the science as well. And just the general concept of a performance test is to bring down what you've done from questions 1, 2, and use it to solve the remaining question or the subsequent questions. So we're using this 40 meters square that we got from question 2, and we can either multiply it by 2, that will tell us the amount of chickens that can hold in the coop. Or, I'm gonna put a big or here, we can divide it, because it says that we should make sure that each chicken gets approximately 1 meter square in space, floor space. So we can divide that 40 meters square by a half. I presented this option here at the top because this would probably be an easier thing for most students to do. When you're dividing by a half, it's the same as multiplying by 2. So we can now say, simply because if you're dividing a fraction, you have to flip the reciprocal and multiply. So this here, this method here, we would flip the 2 to the top, bring the 1 at the bottom. And I'll do this in other videos just to show you how to do division of fractions. But this is basically what you have to do in order to solve this mathematical sentence at the top. So this will give you about the same 40 times 2, and it will be 80. I just took out the meter square here, so I'm going to put it back on. Either option will give you 80 meters. Well, not the meter square, sorry. It's actually 80 chickens. Up of chickens. So the maximum number of chickens that will fit in the coop is 80 chickens. All right. Let's move on to number 4. The instruction reads, the table below shows the number of chickens that 3 parents wish to donate. Use the information in the table to help you answer question 4. This question is from the number strand, and we're going to be selecting data relevant to the problem when finding its solution. In this question, we're required to communicate our reasoning by constructing an argument based on reference to the maximum number of chickens that the coop can hold. So parent Miss Gray wishes to donate 100 chickens. Mr. White wishes to donate 70 chickens. And Miss Brown wishes to donate 50 chickens. So the question reads, based on your response in question 3, which parent donation would you suggest the school to take? And you should explain your choice. So based on the answer that we found out in question 2, that there were 80 chickens, and that's the maximum amount of chicken that the coop can hold. We could not take Mrs. Gray's option because that's clearly more than what the chicken coop can hold. We don't need to go as low as 50. We can, because that would leave the space for approximately 30 more chickens. We can definitely go with Mr. White's donation, which is 70 chickens, because it says approximately, so it might not hold the 80 chickens. It's just, that's the maximum number. So the closest number to the maximum, or the approximate number, is 70. So we will definitely go with Mr. White's donation. And I've already explained why we need to go with Mr. White's donation, but I'm going to just put it in writing. So I can say the best option of parents donation to accept is Mr. White, because, let me just keep it very simple, because the number of chickens he wishes to donate is closest to the maximum number of chickens that the coop can hold. And that would be our answer. And that clearly will suffice. Let's move on to question 5. Question 5 reads, the chickens need feeders from which to eat. 10 chickens use 1 feeder. Based on your response in question 4, how many feeders will be needed for the farm? So in question 4, we would have chosen Mr. White's donation of 70 chickens. So based on that response, we could say that for 70 chicken, we're gonna write it out. I always use statements. We can say for 70 chickens, we will need, I'm just gonna leave this option. I'm gonna write it in afterward, dash feeders. I'm gonna write it in after I do the working out. So if we have 70 chicken and it says 10 chicken to 1 feeder, so 10 chicken, 1 feeders, 20 chicken, 2 feeders, 30 chicken, and you can do it as simple as that. 30 chicken, 3 feeders, 40 chicken, 4 feeders, 50 chicken, 5 feeders, 60 chicken, 6 feeders, 70 chicken, 7 feeders. So as simple as just counting up by the tens and then going up with the feeders. So we could actually draw a little table here It's whichever option works for you. We could simply, and I'm going to put the or again here. We could simply just say that if it's 70 chickens, we could divide 70 by 10. And clearly we know that 70 into 10 is 7. That's short division. 7 times 10 will give you 70. So we know that the option is 7. 7 feeders. We can't actually just put 7 here because we know that's correct. Or we could put a little diagram like this and then say, for one column or a little table, let me use my typing tool. So we could say feeders, like what I said, and then put chicken here. And simply like what I just said, for 10 chickens, 1 feeder, 20 chicken, 2 feeders, 30 chicken, 3 feeders. I won't finish it. You can clearly just finish it at home. But that's what it looks like. We'll get the same 7. All right. And really, that's the end of the performance task? No, we have one more question. I preempted. All right. So in this question, it was also from the number strand, and we were supposed to solve real-life mathematical problems involving division, which requires us to calculate the number of feeders needed based on the number of chickens. Our objective was to differentiate between the use of addition and multiplication, subtraction, and division in problem situation. All right, let's move on to the last task, or the last question for this performance task. It says a farm store has 2 options when selling the feeders. The options are outlined in the table below. Use the information in the table to help you answer question 6. Option A, the feeders are sold individually. Option B, the feeders are sold by the case. So for 1 feeder from option A, it's $300. And then for option B, they sell 1 case which has 5 feeders for $1,300. So the objective, this question is also from the number strand. So we saw that for this entire performance task, we only had 2 strands, the number and the measurement strand. The objective for this particular question was to select data relevant to a problem when finding its solution. And we were required to make sense of the problem by analyzing constraints, and those are the information there, given in order to choose an option based on the cost that it is better for the school, and to explain, based on the cost that is better for the school, and to explain our choice. So basically here, we're gonna have to select the feeder that is best. The feeder, the cost of the feeder must be calculated correctly, but it also must use your answer from question 5, right? So we knew that we needed 7 feeders, right? So clearly 5 feeders cost $1,300 for option B, but 5 feeders for option A would cost $1,500 because 5 3 is 15, 5 300, 1,500, right? It might seem like a good idea there to choose option B. However, remember that the feeders are sold by case. So you can't buy 2 more feeders from option B. You have to buy another case, which is 5 more feeders. So if we buy 5 more feeders, which is another case, that's $2,600 because 1,300 plus 1,300 is 2,600. We don't need 10 feeders. We would have 3 extra feeders, which is totally unnecessary. That is something that we must bear in mind. And for option A now, while 5 feeders is 1,500, and if we were supposed to buy another 2 feeders, that would be 2,100 or 2,100. It is the better option because we would save the additional $500 of purchasing 3 feeders unnecessary that we don't need. All right, so it's definitely option A. So we can go ahead and explain our choice now to say option A is better for the school because, and I'm using this as a clear statement to say because the school only needs 7 feeders. And we can only purchase feeders per case from option B. If we were to purchase 2 cases, it will give us 10 feeders. 3 extra feeders that we do not need for an additional $500. Because as I said, it would be 2,600 to purchase the 2 case. So we can actually put it here. If we were supposed to purchase 2 case for 2,600, it will give us 10 feeders, 3 feeders, 3 extra feeders that we do not need for an additional $500. And we could just go back to say that put the cost here for option A. Option A is better for the school because the school only needs 7 feeders. This would cost 2,100. But that's very clear now. So we can just read over our option, our answer. Option A is better for the school because the school only needs 7 feeders. This would cost $2,100, and we can only purchase feeders per case from option B. If we were to purchase 2 cases for $2,600, it will give us 10 feeders, 3 extra feeders that we do not need for an additional $500. I think that's really clearly states why we chose option A and why it is a better option. So there we go. That's the end of our performance task. And if we did similarly to what I would have done on this paper, it would have been clearly 100%. So I wish you all the best in your examinations tomorrow, grade 4 PEP stars. Please, if you're not a grade 4 student and you're watching this video, please share it to any grade 4 student that you know who is going to be doing the examination. I have the grade 6 papers that we did this year. I have the grade 5 papers, and I should have the grade 4 papers by the end of tomorrow. So please look out. I'll be doing the reviews for all of those papers simultaneously. So you can stay tuned for those videos on the website, as well as many other resources that I am to share in the future. Thank you for watching my videos, and continue to share, like, comment, and subscribe to the channel for all your PEP related materials. Enjoy the rest of